Dear friends, today we are going to learn about definite and indefinite integrals. So, here first what we are going to do is, we know that an antiderivative of f of x, what is that? It is a function again f of x such that f dash of x is equal to small f of x. In this case, we will write that capital F of x, it is equal to integral over f of x dx. The function on the right hand side of the above equation is called the indefinite integral of small f, and small f is called the integrand. The notation and terminology are consistent with our fundamental theorem of calculus which we have learned before. We can rewrite the fundamental theorem in terms of the indefinite integral in the following way. How can we rewrite it? That is, integral a to b f of x dx, it is equal to capital F of b minus capital F of a, that is equal to f of x within the limits small a to b integral f of x dx within the limits small a to b. So, here the lower limit is a and the upper limit is b. An expression of the form integral a to b f of x dx with the end points specified a and b, it is known as the definite integral. Now, we go directly into some problems. Problem number 8. Check the following integral, integral 3t square by 1 plus t cube the square dt, it is equal to t cube by 1 plus t cube plus c. Next one is evaluate integral 0 to 1 3t square by 1 plus t cube the square into dt. So, for the first one, what will happen? That is, the derivative of a constant is 0, we know that. Use that result and you will use the sum, quotient and power rules. So, for the given problem, we are going to see the derivative d by dt of t cube by 1 plus t cube plus c. What is the derivative of that? That is d by dt of the first term, t cube by 1 plus t cube, plus the next term is d by dt of the constant, that is c. So, in the next page you can see that when we are doing the derivative, we are making use of the quotient rule. So, 3t square into 1 plus t cube minus t cube into 3t square plus 0 whole divided by 1 plus t cube the square. That is the first derivative, first part the derivative is given, the second the derivative constant is 0. So, you will get 3t square plus 3t raised to 5 minus 3t raised to 5 by 1 plus t cube the whole square. You can cancel t raised to 5 term, you will get 3t square by 1 plus t cube the square. Hence, by the definition of integral, indefinite integral, you will get integral 3t square by 1 plus t cube the square dt, the value equals t cube by 1 plus t cube plus 3 plus c, the constant. Now, in the next problem, in the part A, we have just proved d by dt of t cube by 1 plus t cube, it is equal to 3t square by 1 plus t cube the square. So, by making use of the fundamental theorem, we will get integral 0 to 1 3t square by 1 plus t cube the square dt, it is equal to t cube by 1 plus t cube within the limits 0 to 1. So, when we are seeing about the limits, you will get integral 0 to 1 t cube by 1 plus t cube. So, you will get the final answer 1 cube by 1 plus 1 cube minus of 0, that is equal to 1 by 2. Now, we are going to see some properties of definite integrals. So, we know that we often want to add, subtract definite integrals, multiply the integrands by constants and compare them with other definite integrals. To perform these operations, we need the following rules for the definite integrals. The rules which are satisfied, the first one, that is integral a to b f of x plus g of x into dx. That is, you are splitting it into two, integral a to b f of x dx plus integral a to b g of x dx. It is called the sum rule. The second one, integral a to b f of x dx, that is integral c f of x dx, that is equal to c into the constant c into integral a to b f of x dx, where c is a constant, it is named as the constant multiple rule. For the third one, if b is lying in between a and c, that is a less than b less than c, what will happen for integral a to c f of x dx in a big interval? You are splitting it into two because b is lying in between a and c. So, integral a to b f of x dx plus integral b to c f of x dx. The fourth one is f of x is c, a constant. What will happen then? Integral a to b f of x dx, the constant is c. So, integral f of x dx will become c into 1 into dx will become x. The limits are from a to b. So, you will get c into x within the limits a to b will become c into b minus a. So, if there is a constant, you will put that constant out and you will subtract the upper limit minus lower limit. The fifth one, if f of x is less than or equal to g of x for all x, which is satisfying a less than or equal to x less than or equal to b, then integral a to b f of x dx is always less than or equal to integral a to b g of x dx. So, these properties hold for all functions f and g, that they have integrals. However, while it is technically a bit less general, it is much easier to deduce the properties from the anti-differentiation and the fundamental theorem of calculus. So, assuming that not only f and g have integrals, but they have anti-derivatives in well, only such problems could be worked out. Now, in the problems which we are going to do worked out in 9 and 10, we have proved the properties 1 and 5. The rest are left as exercise for you, dear students, and we will go to the remark. We have defined the integral a to b f of x dx, where a is less than b. However, the right hand side of the equation integral a to b f of x dx, it will be becoming what? You will get it as f of b minus f of a. Now, for the final slide, we are making some sense such that what will happen when a is greater than or equal to b. Hence, let us define the integral from a to b when b is less than a as follows. If b is less than a, f is integrable on closed interval b to a, that is, there is a shift in a b, we are shifting it as b a. So, we define integral a to b f of x dx could be written as minus of integral b to a f of x dx. That is, when we are changing the interval as a to b into interval b to a, the sign in change is important. If a minus b, then we will define it as integral a to a f of x dx. What will happen? The upper limit and lower limit are the same, means the integral value will be equal to 0. In accordance with these definitions, we can say that the fundamental theorem is true for all values of a and b, for a less than b or a greater than b or a equals b. The last one, if a equals b, is the thing which we have to do, that is integral a to a it will become. So, by this I hope you know the concepts, basic concepts for definite integral, and also some important properties which we have to know about the definite integrals. So, we will meet in the next class. Thank you, friends.